Can you hear me? Good morning, everybody. I want to thank you to join us in this workshop that was organized by Fernando Salvagiotti and Dr. Walter Carciochi, who will appear later. He's in an internship in research in Nebraska. Fernando, Walter, and myself are CONICET researchers, so we are aware of the fact that it is key to generate scientific evidence. We are 3 professors in national universities. We also believe education is key. And as we are here today, we believe is that it is important to give information to you and try to give an answer to the farmers regarding dynamics of nitrogen in corn veg, but always evidence-based. Where are we standing today? And as regarding nitrogen in corn, we are standing in this situation. We are blind because we don't measure much. When we think of nitrogen in corn, we are sort of faltering in our steps. We know that there is a yield gap and nutrient or nutrition gap in corn. The title here says a yield gap, and the gap is about 50%, is half the yield. And in these factors, nutrition is key, and nitrogen would be the silver bullet to increase yield. We take this information from the past 3 or 4 years without taking into account La Niñas. The corn yield in the Pampas region are 7,600 kilos with a nitrogen rate of 70 kilos and also a rate of sulfur and phosphorus. We already have nitrogen limitation in corn. Any efficiency indicator that you use, you will see that we produce corn based on what the soil gives to us. That is not sustainable. No way. We didn't want it to continue producing 7,600 kilos of corn, but we rather want to close the gap. And this would imply about 11,500 kilos. But for this, we need higher nitrogen, phosphorus, and sulfur input into the system. Almost 50% of increase in nitrogen if we want to close yield gaps in corn. The current context is we measure little, we have nitrogen limitations, and we want to produce more corn on top of that. In this context, we ask ourselves, what alternatives do we have to introduce more nitrogen to the system to supplement chemical fertilizers or to supplement nutrients recycling? So here is when the veg comes in. That is adding this to our crop sequences in order to contribute with a credit or a penalty. That is something that we will see. But also, which is not a minor detail, is that we introduce more nitrogen to the system in order to fix more carbon, to build organic matter. It's not enough to have more grass crops if we don't add nitrogen. We ask ourselves 4 basic questions, and we try to find what scientific evidence do we have to support that. The 4 questions that we ask ourselves, or 4 ideas, is there a nitrogen response even when we have a veg already in that corn? Second, how much when how much nitrogen is contributed to that veg and when. The two questions will be answered by one of the members of the panels and the other two by Fernando. What is the veg contributing beyond corn, and what are the benefits in the long term? Walter will appear at any time. And the first question is, Walter, whether is there a nitrogen response even when we have veg as a first crop? Walter, I don't know if you are muted or we are muted here. Can you hear me? Thank you, Nahuel, for your introduction. This question came from advisors or from farmers, because they say that nitrogen didn't make anything because there was the veg as a first crop. So we try to evaluate this. We collect data, and we made a database with 70 trials in the Pampas, and the response to fertilization with nitrogen in corn from fallow and from veg as a second crop. In this chart, we can see the variability that we have in this nitrogen response after fallow, and the answer was about 1,800 kilograms per hectare. What happens now when that corn has a veg as a first crop? We see high variability, and the average that response is 1,200 kilograms per hectare. Answering to the question, is there nitrogen response even with veg as a first crop? Yes, there is a response, but it is lower if we have a fallow first. So there is a contribution of nitrogen to the veg, but it's not enough to meet the requirement of corn. How can we predict this variability in nitrogen response? The logic thing would be to measure what is the nitrogen contribution from that veg and what's the relationship between the nitrogen response in corn and the accumulated nitrogen in veg. In the right, we see that we measure the air biomass, which is easier to measure, the biomass of the veg. So we can see the relative yield, which is the ratio between the non-fertilized corn and the fertilized corn. So in lower values, we have a high response to nitrogen. We see that there is a significant correlation between this and biomass, because we have biomasses of 5,000 or 5,200 kilos per hectare or higher than that. There is low response of nitrogen. If we have an accumulation in the veg of 60 kilos of nitrogen, the response probability goes down. The capacity to explain that variability in nitrogen response is low. The contribution of nitrogen from the veg explains part of that variability, but it does not give a complete answer. What we did with these 70 locations, we used the methodology that includes regression trees. We consider different variables that will impact the variable to our response, which is the nitrogen response in corn. So we took into account climate conditions, soil conditions, veg management variables and corn management variables. Here we see that the average for these 70 sites, the nitrogen response was 17%. The range is 20 to 87%, so the range is quite broad. All these variables help us explain this variability. The first things that we saw is that nitrogen limitation in that environment was the main variable that enabled separating groups of high and low response. This nitrogen limitation was evaluated as a nitrogen response in corn in fallow. With the yield monitor, we are able to establish what is the nitrogen response, or using specific models, we can also identify what the nitrogen response is. This tells us that this environment, which limits nitrogen, will also be limiting the nitrogen, even if I use the veg. What we analyzed was when we have a high nitrogen contribution for the veg, we have a lower yield per hectare. We also considered the different variables that allowed us to separate a high or low response to nitrogen. This water balance is an atmospheric balance, which is rainfall less reference evapotranspiration. I don't want you to only look at the red numbers, but it's just to see what are the variables that are impacting on that nitrogen. In the left, we see that there were two other variables for separation. One was the organic matter content in the soil. Higher the organic matter, higher the contribution, and water balance or water availability, but concerning the veg in corn. This allowed us to separate this different locations in high and low. To summarize, there is a high probability in the nitrogen fertilization in a corn that comes after a veg than in other sites where there is a low accumulation of nitrogen with veg, appropriate water availability, and low organic matter. So these would be the conditions that would allow us to have a high nitrogen response. And the second question, when is this veg nitrogen contributed? So we evaluated the synchronization of nitrogen. How does the nitrogen corn demand works, and how does the accumulation of nitrogen works? So we evaluate this in time, starting with the planting date, and then we consider the nitrogen release or breakdown, and here we see what's the remaining nitrogen that tells us how much nitrogen has been released. We can speak about an early release or a late release. When we evaluate the probabilities of water limitation in a corn growing after a veg, we see that the water availability is quite low. We saw that 65–70% of the veg nitrogen was released at the flowering R1. We evaluated the rate, the release rate. How many kilos of nitrogen per hectare per day are being released per day, and how many is being released by the veg residue? we made an overlapping, an overlaying of these two curves, the generation rate and the release rate, and we calculated the percentage of these two curves that are overlaid. Considering the total area below the curve of corn nitrogen accumulations, we see that it is released in an early moment. We see in that case an overlapping of 41%. When we have a late release, we improve that synchronizing or that overlapping by 61%. Not all the nitrogen that is released is available when the corn needs it. We see that at the moment of physiological maturity, there's still nitrogen that is being released by the veg. So the question is, what happens with that nitrogen that is not used by corn? How don't we analyze this at the level of systems or sequence? Then the question arose, let's look beyond the corn. What happens with this nitrogen? I will give the floor to my colleague so he can answer the questions. Let's see what happens beyond in the long term. What is the role of intensification, sustainable intensification or regenerative agriculture? These are the same things that help us solve our problem. These are the results that we had in Oliveros in 2006. We have different rotation, monoculture and soybean, and the numbers below tells us what stays in the soil, then the cover crops, for instance, veg. In this sequence was repeated. We added a soybean to all of them to see the residual effect. What we see here is the residual effect after intensification. All the sequence, the blue one, which is more intensifies, that covers cover crop, soybean and corn. In the first case, we have a significant effect of this management because we know what veg is like and what will happen with the next crop, but the cost is not here. This soja was in a Niña year. It takes the advantage of the cover crop in the long term from the water retention or microbiological point of view. So this had a significant economic impact. This would be the big picture that we have to see. We will consider the crop, and then we will end up making numbers in our production system, which is what I do when I work with my plot every day. How much are we receiving? We wanted to make an exact calculation. This trial over 2 years in southern Santa Fe, that was late corn. We have different first crops, and we wanted to see what was the original nitrogen contribution. The response of native nitrogen fallow over 8 months has a lot of nitrogen. We know that late corn has a good yield. The contribution of we are considering the fallow contribution and the veg contribution. We are not looking at what would be the net contribution of veg. When I plant the veg, I have to consider also the cost of the seed. What Walter was showing, what happens with that nitrogen that is not being used. Some consultants said, or some farmers say, here I planted wheat and I planted veg, and the wheat is greener. And then we followed this with corn, and we also calculated what was the nitrogen contribution. But you can see that we have 11 or 12 more kilos of nitrogen. So if I add how much nitrogen this sequence is adding, it is 45 and 50 additional kilograms of nitrogen that in the whole system that has been used by the late corn, but also by the following crop. In terms of nitrogen, we are having a significant contribution in the medium term. I think that these are interesting numbers to bear in mind.
Here we see the response on that wheat planted after corn. And when we see these response curves of nitrogen to wheat, you can see the yellow line, that's the soil contribution. Any nitrogen curve you see, you first have to see 0. And you will see what it is telling you. So wheat planted on veg the previous year are always above. That's a first observation. So you need to take soil samples to know what the nitrogen content is. And the second point is that that nitrogen is not enough for production. It's not that I plant wheat and I'm done. Because there is a response curve that will be lower if compared to the veg curve, which is the fallow curve, which is the blue one. You can see corn on fallow that was not fertilized because I thought it might be enough. Then the nitrogen availability will be lower. So veg is contributing, among other things. It's a cover crop. It helps us control weeds. But those are the figures we have to add up. Here we have concrete figures about nitrogen. Now, we've only seen one crop. And what happens beyond the crop? And this is another long-term experiment that gives us a lot of information on what is happening. This started in 2012. We compare different sequences. This is veg, corn, soybean. So there is a grass. You can add grass or wheat, corn, soybean. It depends. You may have different sequences. And you can see nitrogen contributions. So we added everything. Every year we would go harvest with measuring the grain, not estimated figures. We would see how much was released through the grain. And here I'd like to make a comment. Usually when we talk about veg, we say veg, and you already assume that veg is contributing nitrogen. But biological contribution is just 1%. Between 55 and 60% of nitrogen in veg is what is actually contributing to the system. The whole nitrogen is a little bit below that. It's not 100%. So what we did basically was what is in green is what got into the system, that is the input, biological contribution. It's 2 cycles. This is what we got in 6 years. This is what we got through fertilizers. And what I'm interested in the long term is a delta N. But you can see almost 340 kilos of nitrogen. But you can see the other sequences with a low percentage of legumes. You can see that there is a balance, which is slightly positive. You have to divide that 40 into 6 years, or the balance is partially negative. This is when we have grasses, but what happens if we have more legumes? In this case, it's same liquids, veg, garden bean, wheat, and fallow. So there is a nitrogen contribution from the air. When we do our calculations, you can see that veg has a net contribution of almost 379. We also have wheat, and when you do your calculations, you can see the number is quite high with garden bean, garden pea. Well, you can decide what happens with garden pea. It's also a legume in winter that will also help to fix nitrogen, but it exports a lot too. And this tells us what's actually happening. If we have grain legume, what we're seeing is that it's not enough to contribute what the plant needs to produce protein. But the impact is not so big in the long term. But the only way in which we can add nitrogen into the system is by adding a crop so that we will not be exporting nitrogen during some time window in the year. So if we want to capture carbon, the situation is similar. We need to have net nitrogen contribution. In order to do this, we need to have legumes, and this is related to biomass, and this is what Walter told us. The important thing is that this is not magic, this is not an input, it's something we're adding into a production system, so we need to see how to add it, whether through early corn, late corn, early planting or late planting of veg, and there are several decisions to be made. What we have to do is to design our production system so that we can get the greatest contribution. Well, this is what was missing in the slide. So nitrogen management presents some challenges. It's not a linear process. We can take the simple path. It's simple, but very frequently it's going to be the wrong way. That is not analyzing the soil, not considering the situation, not having a number that is at least close. But what we want to show here through this presentation is that it is important to have local data, and we do have the data. 10 or 15 years ago, I did have the data, and the answer is not legume. We know that legumes will contribute to fixed nitrogen. We know how much nitrogen will be fixed, and there is a lot to be said about this. We only have 20 minutes, so we hope we will be able to answer the audience's questions. So we're following that complex path, but which is the right path. We need to have more people because we need data. Thank you. Thank you. Remember, there's a QR code on the screen so that you can scan it and send your questions. Walter is hearing us. Maybe we can have Walter on the screen. I will be addressing the questions to the different members of the panel. Walter, if you're hearing me, there is a question for you. Considering planting of early corn, can you take advantage of the N that is contributed if you do not have veg in August? I'm sorry, I can't hear you very well. Early corn, whether you can take advantage of the nitrogen veg that you eventually burn in August, quite early, veg that is finished quite early. Okay, maybe you can answer, Fernando, and then I will write the question to you. That's a good question, and I think the answer is very much related to how we fit the veg into the system. Let us not decide in May, because then we will have a late corn or early corn, which is even worse. There was a very good slide that showed that it's related to biomass, and evidently if you plant veg kind of late, you will not have the biomass that contributes the nitrogen you're needing. So you need to do some planning. You can say, I will do soybean or corn in summer. I'm already thinking of veg because I will have corn the following year, so I'll try to focus on having my veg as early as possible, because we need the growth explosion as early as possible before winter gets here in June or July. So I think we have to think of this in advance. I'm sorry, I was able to hear now. At least here, what is key for us is to adjust veggies planting day to do it as early as possible, because as you were saying, then winter comes, growth rates are quite low, and you do not get good plant standing and cover. So what is key is to plant as soon as possible to get a good biomass, to dry early if you're going to early corn afterwards. Thank you, Walter. There's a short question for you, Fernando. Let's try to have short answers. What is the burning day for veg? Which one is early and which one is late? It depends. I think, and Walter also showed this, maybe you can see slides, early or late depends a lot on water. I think there are two things to be taken into account. First of all, whether you're going to plant early or late corn. Then the water input and the soil capacity to accumulate water. That is the basis to plant veg. So the decision to plant early or late vicia. If I have late corn in December, I may extend the burning until the end of October. I still have the whole of November. But with early corn, we are too close to the drying date. Drying time, I would say no longer than August. I'd like to clarify something. Walter showed some graphs, and late time is 1 week before planting, and early is 1 month before corn planting in the southeast of Buenos Aires. That is planting corn end of October. Walter, can you hear me? The question here is, what you're calculating nitrogen synchrony and asynchrony on what corn and wheat yield? That is, if there is no overlapping, do you think that you lose it into the system? Well, veg that was burned early accumulated 110 kilos of nitrogen, and the late one 190 kilos. This is by optimizing veg planting time, and corn in that case gave us about 14 tons. And what you're seeing is that asynchrony, as we see, most is released in the early stages in corn, where the nitrogen demand is still low. But obviously, it will depend on the year. If there is not too much water, the logical thing is that that nitrogen will stay in the soil and will be available for corn, so that would not be an issue. But if we think of the best thing from an environmental and economic point of view, because if you lose that nitrogen, that may have a negative impact on the environment, the best thing would be to synchronize that. But as Nahuel was saying, these were tests carried out in Balcarce. When we studied historical data, weather data, climate data, we saw that rainfall that usually takes place between the planting of corn and the time when corn water requirements increase, that is time enough. If we go and measure water in the soil in veg or in a corn planted after veg, we see no differences. So in most cases, it's enough to go back to the necessary profile. Thank you, Walter. There's a question for you, Fer. There's a question that we always get. If we think of veg plus grasses, and if we fertilize that with urea, what impact can that combination have on the next corn? We are talking a lot today about associations, but we know that when you mix legumes and grasses, well, it usually favors grasses. But if you see veg and grasses, you see grasses grow first and veggies go behind. We need more data, but if we add nitrogen, that will favor the growth, and the veg will not be able to win. It depends on the soil fertility, but basically that's a general behavior you might expect. So when you associate, you try not to fertilize, you may use phosphorus because this is for the grasses not to work this way, but we're studying this to see what the dynamic is, because usually one grows faster than the other one, the demands are different, but nitrogen fertilizers usually make grasses to grow faster and win over veg. Okay, let's continue with our questions. We still have 10 minutes to go. There is a grower and an advisor here who mentioned something that may have been mentioned by Walter, but I'm mentioning this again. In practice, what can we do to add veg to our diagnosis models? What can we measure? It's a good question. It's like the stage we're missing in connection with the conventional diagnosis models. There is some work that was done in Balcarce where this was assessed. We have to see the soil nitrate. In Balcarce, we worked a lot with an indicator that shows nitrogen mineralization, and usually the models we developed to define the need for nitrogen fertilizer in corn is based on this. And what we've also seen is that if we are to think of veg only, the kilos of nitrogen accumulated in that veg improves the diagnosis models. And this is what I showed in my slides today, both when we had the regression trees on the accumulated nitrogen and relative yield ratio. And veg is one of the factors. If we consider in general terms cover crops, there is another variable to be taken into account, which is a carbon nitrogen rate in that cover crop. So nitrate, kilos of nitrogen, and carbon nitrogen rate. That would be the model we're using now to be able to adjust nitrogen fertilizers needs. And if I can add something to what Fer said today, we also assess the associated crops. Well, to start with, we do not fertilize the associated crops. I don't think there is a benefit there. Even though grasses accumulate more nitrogen when associated with a crop, what is key is the legume-grass ratio, so that we will not have an excess of grasses, and so that there is no excess nitrogen. We'll have to fertilize more than if we had veg only. That if we have fallow only. Our theory was that we would have a better synchronization here because nitrogen release will be slower, but for the time now we're seeing that the behavior is similar or even worse than veg. But again, this depends on the proportion on the grasses and legumes ratio. Thank you. You have answered several questions that we got here. There are many more. Another question is whether veg's nitrogen is lixiviated, whether nitrogen in veg is leached. In terms of leaching, it doesn't matter where the nitrogen comes from, nitrogen, veg, or soil nitrogen, and that's it. This is a question for you. When you have most of the veg going quickly, is it better to use fertilizer in more advanced stages of the corn rather than go to early applications with solid products? Well, it depends on the type of corn, whether it's early or late corn. With late corn, you have very little time to go to the field because in between you plant and you get the leaves, at least 25 days have gone by. So I got a diagnosis method. I think that the solid sources or liquid sources are both okay at the beginning. The important thing is to have the right doses, to do a diagnosis, to do soil sampling, but that's the most important thing. Early corn. Well, it depends a lot on synchronization, and what we're seeing as a general rule is that when you have 5,000 kilos of dry matter with veg, you may not have a good response. Let's go down for veg giving us less and have a threshold we are familiar with. Walter, short answer. How many kilos of nitrogen does every ton of dry veg contribute on average? Well, very recently we assessed that variability, but in general terms the concentration of legumes is quite constant, and you may say that it's contributing about 30 kilos per ton. It's about 3% of nitrogen. Which would be the logical rotation to plant corn after soybean as a second crop? Would it be okay to have harvesting in April and then you have wheat as a second crop? You have to find the way to plant it with veg at the same time. There are some experiences that show what happens when you plant veg, in the case of soybean, before the leaves fall, because the seed, there is an important thing here. We complain that veg is expensive. So when we do bulk seeding, we need to wait for the leaves to fall, and so that they will cover the seeds and the plant will grow, but we need to increase the dose. And it depends on the germination power of our veg. I think the economic risk is higher than with conventional risk. Another specific question for Walter. When would you recommend doing soil sampling to correct nitrogen in corn, having had veg as a first crop? I'm sorry, I could not hear your question. When would you recommend to take soil samples in corn, considering veg was the first crop? Well, the model I described worked very well when corn was measured in B6. But if you measure nitrate when planting corn, depending on when the veg dried, you may already capture that part of the veg effect. And we've also seen that the NAN, this mineralization indicator, also increases a bit when the first crop was veg. This may be associated to Fernando's simple answer. Let's measure veg's biomass. This is simple. If it's above 5 tons, then there is a low probability of response to nitrogen. If it's less, then let's take samples of nitrate and none. We can use that value if we already have it, and let's try to use conventional methods. Thank you, Walter. There is another question I have here. Good afternoon. I have the following question. You are mentioning none. What is the real contribution of nitrogen that comes in mineralized nitrogen in anaerobosis? None is helps us estimate nitrogen that is mineralized during the planting cycle, in the crop cycle. And in corn crop, almost half of the nitrogen that is absorbed comes from mineralization. That can be estimated with none. We do not get anything from none. It's just a more practical indicator than the traditional method to measure mineralization. The big problem we have, as you all know, is that our soils mineralize half of what they used to mineralize at the beginning, and you can see this in any organic matter map.
So our soil, although we oftentimes look at this indicator, in most cases they mineralize less, and our corns are limited by nitrogen. We have 1.20 minutes left. This is para Fernando. If the P is not, if you wouldn't harvest pea grain and it is interrupted, would it have the same? Would it make the same contribution of nitrogen as to the veg? The pea we don't reach the quantities or the amounts that we expect. If we want to use pea as a cover crop, the calculations that we made was with pea planted the end of July, and it was harvested by the end of November. But we should think for longer development terms, and we shouldn't export it. I think that we need 5,000 kilos of pea in order to have the same effect. There's some questions left. You can contact Walter by mail. Fernando will continue being in the Congress. I thank you for joining us, and I hope this has been helpful for you to make decisions.